Hey guys, it's Blake here. Today we're going to move on to combinations of functions and composite functions, section 2.6 in your textbook. So the first thing we want to talk about is domain. Understand domain is your x values, right? And the only thing you're really going to have restrictions on, is if you have a fraction, you can't divide by 0. You can't have a 0 in the denominator. And if you're taking a square root or any even root, you shouldn't be taking the root of a negative number. So those are basically your two things you want to watch out for. You want to watch for fractions, make sure the denominator is not 0. And you want to watch for even roots, make sure that you're not taking the root of a negative number. So here I don't see any of those. So my domain is going to be all real numbers, right? Negative infinity to positive infinity. There's no restrictions here. Here we see that denominator, right? Remember, your denominator cannot equal 0. So x squared minus 49 cannot equal 0. So we want to find out what makes it equal 0. We're going to go ahead and factor this. This is difference of squares, so x plus 7, x minus 7. So we know that x cannot equal 7 and x cannot equal negative 7. Those are our restrictions. Now, how would I write that? Let's start with negative infinity. We can use everything from negative infinity all the way up to negative 7. We cannot use negative 7. And then we're going to use that union symbol because we can also have negative 7 all the way to positive 7. Can't include either of those. And then we can round it off with 7 all the way to infinity. All right, next one. Remember, you can't take the square root. Well, it's imaginary, but we're not going to take the square root of a negative number. So we know 9x minus 27 has to be greater than or equal to 0. We need that number to not be negative. It can be 0. So we're going to add 27. 9x has to be greater than or equal to 27. And we're going to divide by 9. X has to be greater than or equal to 3. And again, putting that in that interval notation, we're going to say x has to be greater than or equal to 3. So we're going to start at 3, and we want to go all the way to infinity, everything greater than. Remember, 3 gets a bracket because, yes, we can equal 3. You can take the square root of 0. Here we got a double whammy. We have a denominator and a square root. All right, we have a denominator and a square root. So we need, remember, you can't have a 0, right? So we don't want this to equal 0. And you can't have a negative that you take the square root of, so we also can't have it to be negative. So we need this to be greater. 24 minus 3x has to be greater than 0, right? It can't equal 0 because then we'll have a 0 in the denominator. And it can't be negative because then we'll have the square root of a negative number. So we're going to subtract 24. So we got negative 24. And then we're going to divide by negative 3. Remember, when you divide by a negative, it flips that sign. So we've got x is less than 8. So we want everything less than 8. So we want negative infinity, right, all the way up to 8. And we don't include 8 because, remember, 3 times 8 is 24. 24 minus 24 is 0. We can't have a 0 in the denominator. So we don't want to include 8. All right, moving on. Combining functions. You can add, subtract, multiply, and divide them. So this is telling you to add f of x and g of x. So we're going to have x minus 5 plus x squared minus 1. And we're going to go ahead and put that in standard form and combine any like terms. So we'll have x squared coming first. We have an x coming next. And then negative 5 and negative 1 make negative 6. And you're done. You added them. So that would be your final answer. You can also subtract, but make sure that you distribute that subtraction because it's minus all of g of x. So it's f of x, x minus 5, minus all of g of x, so minus x squared, and minus negative becomes plus 1. So make sure that minus sign distributes. Put them in standard form. We got negative x squared plus x, and then negative 5 plus 1 makes negative 4. And we're done. Oh, I totally forgot domain. We'll go back and do domain at the end. We'll finish this up. You can multiply them. So f of x times g of x, and this is just a little FOIL. X times x squared is x cubed. X times negative 1 is negative 1x. Negative 5 times x squared is negative 5x squared. And negative 5 times negative 1 is positive 5. And then we're going to combine like terms, put them all in order, standard form. So we have x cubed minus 5x squared minus x, and a plus 5 on the end. And to be honest, if we look back to all three of these, I'm not seeing any restrictions on domain. I don't see any fractions, so there's no denominators we have to watch out for. And I don't see any roots. And those are the main things you want to look out for. So when we talk in terms of domain, we're at negative infinity to positive infinity on all of them, right? All real numbers. You can plug in whatever values you want. And then part D, we get to division. So f of x, which is x minus 5, divided by x squared minus 1. Oops. Now there's nothing that's going to simplify here, so that actually is all of it. But your domain, notice you have a fraction. So remember, it cannot equal 0. So x squared minus 1 cannot equal 0. So we're going to add 1. We're going to take the square root. So we know x cannot equal plus and minus 1, right? Positive or negative 1. Because if it's positive 1, 1 squared minus 1 gets me 0. And if it's negative 1 squared is 1 minus 1 gets me 0. So we can't have a 0 in that denominator. So let's write our domain. So we're going to start off with negative infinity. We're going to go all the way to negative 1. We cannot equal negative 1, so we're going to leave that open. And then we're going to pick up at negative 1, and we're going to go all the way to positive 1. Again, can't equal positive 1, but we want everything in between. And then we'll pick back up at positive 1 and travel all the way to infinity. All right, and that's it for those. Yes, so there's your answer for that one. All right, so this one is adding our functions. So we have f of x plus g of x. And that's actually as far as you can get. You can't combine those, so you are done. Now when it says domain, we got a couple of square roots here. So again, remember we want these to be greater than or equal to 0. So we want x minus 3 to be greater than or equal to 0. We don't want any negative numbers. And we want x plus 1 to be greater than or equal to 0. So here add 3, x has to be greater than or equal to 3. And x has to be greater than or equal to negative 1. So now you have to think. We need x to be greater than or equal to 3 and greater than or equal to negative 1. Well, this kind of covers both, right? If it's greater than or equal to 3, then it's definitely greater than or equal to negative 1. So we're going to use this one to write our domain. We're going to start at 3. Yes, we can equal it. And we're going to go all the way to infinity. So all these numbers are greater than or equal to 3, and they're also greater than or equal to negative 1. All right. So this is using actual, it's modeling the number of births versus the number of deaths every year after 2000. So it says write a function that models the total number of births and deaths. So we want to add them. So we're going to have, this is part A, we're going to add our two functions, b plus d of x. So we've got negative 2.6x squared plus 49x plus 3994. And we want to add negative 0.6x squared plus 7x plus 2,412. And we're just going to combine like terms here. So we've got some x squared, so we've got negative 3.2x squared. We've got some x's, so we've got 56x, and we've got some constants, which add up to 6,406. And that would be my function for the total. So if you wanted to find the total, that's the function you would use. Births and deaths in a year. The next one says, find the total number of births and deaths in 2003. So again, you have to understand how this X is the years after 2000. So 2003 is 3 years after. So what we're plugging in for X, we have negative 3.2. We want 3 years after 2000. And 3 years. And 6406. We're just using what we created. Sorry. And we're going to get 6,545.2. And this is number of births in thousands. So that's 1,000. Right? Births and deaths. Alright. And we're on the last, nope, we're not on the last one. Hopefully we get this done in 15 minutes. This is composite functions. So you would write this as f of g of x. So I always work from the inside out. So we're going to replace that g of x. We want f of, and instead of g of x, I'm going to replace it with this. Which means I'm going to go to f and I'm going to plug this in. So we've got 5 times something plus 6. And I'm going to plug in 2x squared minus x plus minus 1. Just kidding. Let's distribute 10x squared minus 5x minus 5 plus 6 and combine like terms. 10x squared minus 5x and plus 1. So those are composites. Here, g of f of x, g of f of x. Again, work from the inside out. We want g of, and instead of f of x, we can write 5x plus 6. So that means I want to go to g, 2x squared minus x minus 1. And I want to plug in 5x plus 6. We're definitely going to have a part 2 to this video to finish up. Sorry, guys. So here we've got 5x plus 6 squared, which is 5x plus 6 times 5x plus 6. So you're going to have 25x plus 60x plus 36. And then minus 5x, we're going to distribute minus 6 and minus 1. And we're going to go ahead and distribute that. 50x squared, just kidding, that's a squared. Plus 115x plus 65. Where am I getting 65? That is wrong. Don't look at that. Alright, 50x squared plus 120x plus 72 minus 5x minus 6 minus 1. And then you combine like terms. We got 50x squared plus 115x and plus 65. That's where I was getting it. And you're done. I'm going to pick up part 2 and finish off these notes. Sorry, I didn't know it would take so long.